Thank you for kind introduction, and I'm happy to come here from the tropical city, Tokyo, at around 25 Celsius, to the city covered with snow. I was so surprised. But anyway, I will enjoy, fine day. Let's see. Okay, then this one. The title is a present situation. I will introduce shortly about what's going on in Japanese cellulose, biorefinery project or something like that. See. Okay. This is a report entitled The Market for Cellulose Nanofibers, reported by an independent individual company, but supported by government, so very optimistic, not very scientific only. But anyway, you can see very well the advantageous point of the, what's that? Oh, here it is. Nanocellulose different from the carbon fiber, glass fiber, aligned fiber, and the characteristic point of the cellulose materials. You can make copy from this. This is a report, so how to move the next slide. Maybe I can use another one. Yes. See, this is also the very optimistic 2023 only such amount of the euro. But we hope that by 2032, large amount of the nanocellulose, not only focusing on nanocellulose, but also the cellulose microfibers or cellulose fiber as well. But you can see that most of them are something like a replacement of the present large amount petroleum-based or metal-based materials. So it's very challenging because competitive with the conventional, well-established, cheap, inexpensive, and well-recognized materials. It's very difficult for new cellulosic material. But we hope, and also government expect to improve such nanocellulose-related materials for the establishment of the sustainable society. But you can see there are some hurdles here by 2040 or like this, cost down or such and such. You can make copy later. Okay, this is better. Another point, something like a polymer composite. It's a large amount, film sheet, elastomers, paper fiber, non-woven additives or like this. And this is a time schedule and more market size here. So eventually we are trying to use such automotive airplanes or like this. It's a huge quantity at this moment. Okay. And from 2014 to 2020, the government initiated a nanocellulose forum supporting to expand the nanocellulose application, the scientific fields or like this, but successfully taking over by the nanocellulose Japan. It's the companies are leading, not government. So more application focusing all Japan, nanocellulose society relating groups are actively working. And now, as you can see, so many various kinds of nanocellulose and microfibrillated cellulose are producing the companies at the pilot scale as well as large scale. And see, number 2 shows a mechanical fibrillation, like including microfibrillated cellulose, but most of them use enzymatically pretreatment to reduce mechanical consumption. But others are original, chemically pretreated, tempo, xanthate, carboxymethylated phosphate, phosphorylated sulfate, acetylated AS alkenyl succinic anhydride treated, or zinc chloride, or like this. I will introduce briefly about these point. And the interesting thing, different from the Scandinavian country, may be caused by the cultural difference, but the Japanese, particularly pulp and paper companies, the market is shrinking, so they are trying to change their enterprise from conventional pulp and paper production to a more, let's say, biorefinery focusing sustainable society, just like rayon company in Japan, Toray, Mitsubishi Rayon, Asahi Chemicals, or Crush Rayon, they have changed their enterprise from conventional rayon production to the integrated chemical company based on petroleum resources. Now, the pulp and paper company are trying to, a little bit long span, without any, not only the short span, but a long span, to keeping the employee as much as possible without, firing or shut down the mills. So they are trying to change. So let's see, the government supports such a large amount of budget to the company, 50% supporting, and 50% your company should, have to pay. See, most of them are composite. It means based on the replacement with petroleum-based materials by adding CNF or microfibrillated cellulose. It's a biomass ratio increase and recyclability improved, and also environmental friendly. At this moment, the cost is a little bit high. See, the Kao company, it's cosmetics, commodity companies, and also the polymer company, Nippon Paper, Toso, Dio Paper, PMC, and Daiken, and such and such. And the university laboratories are just hanging down to each project. For example, our laboratory are supporting the Kao company and also Sumitomo Rubber, and like this. So this is so very, as Kare pointed out, there are some, valley, what's that? Death valley. So to improve the level of the death valley to as high as possible, the government support to cross over the death valley as much as possible. So 50% support to company. Okay. And at this moment, the Tempo CNF are applied to various material, but the quantity is not so large. It means, even though at this moment, the price cost of the Tempo CNF is expensive, so only small amounts of high-value materials are available. But if you can increase the production quantity, the price should be down, because the original crop pulp must be 50 euro or something. I'm not sure at this moment, but so it's inexpensive. Just tempo oxidation are kind of one process of bleaching, so not so expensive. But at this moment, the quantity is not so large. That's the reason why the price is high at this moment. But you can see the ballpoint pen. See, smooth ballpoint pen and diaper for super deodorant and such printing board and tires. And the car companies are electronics. And the Toyota, maybe you have at least one or two Lexus in your home, but no, of course not. A very expensive car. But this metallic coating, Tempo CNF, has been used to improve the quality. But only expensive car, not so, Anyway, and at least recently, Tohoku University developed CNF-containing supercapacitors for automobiles, and the Maryland University group solid lithium batteries using CNF as efficient lithium-ion channels. And the Mizuno Sports company develops a golf shaft, let's say. And the Nippon paper, some clothes, and something like that. As you can see, it's a very killer application, but not so large quantity for common composite like this. So we have to expand starting from such high value, small quantity value to more common, large amount of the composite materials. So I would introduce briefly about the what's going on in the company. See, the OG Holdings developed the Auro Visco. Aura looks like dispersion using a phosphorylation, and at this moment using fresh concrete pumping precursor or something like that, but not so large amount. And this is a very good process in terms of the process and industry, but we cannot repeat such short time, high temperature process. So we developed a more mild and controllable system at the 150 degrees C for, let's say, 20 minutes or like this, and obtain the phosphorylated pulp and the nanocellulose. And the main reaction is phosphorylation, but also the cross-link and some side reaction occurred. And OG Holdings developed not nanocellulose, it's a cellulose fiber, and polyethylene fiber, air-laid processing without water, and making such matte, and can hot pressing to make such, in this case, model example, door mirror cover for automotive, and very good sharp impact strength compared with a nanocellulose composite. And the Nippon paper, their trade name is Selampia. One is a tempo CNF applying tire, diapers, and Lexus, and they succeeded to spray dry as long as short tempo CNC. Okay. And another carboxymethylated CNF are already used cosmetics, shampoo, rinse, and also foods. So very slowly but steadily increasing. And Dio paper is a famous paper for the toilet paper or tissue paper. And they also prepare the mechanically fibrillated LX by 89% energy reduction was succeeded. And the Hokuetsu University developed a partially fibrillated using the zinc chloride board. It's very strong. I brought this board. So if you have experience of sports, arm wrestling, or military, try to bend this, but don't do 100% force. Anyway, very, very strong. It's a board, and partially found that nanofibrillated. Okay, Yano sensei in Kyoto University retired this March, and they developed the Kyoto process by the continuous from wood chip, pulping, bleaching, and compositing to make sure component and symbolic color. And we are now focusing on the natural rubber, CNF, and additive composite, because the commercial tires are almost all made of petroleum, so running petroleum. Carbon black from the insufficient incineration from oil, and synthetic rubber is also as well. So the tires are forming so many dust to our lung, and I'm not sure. I think the Europe has strong pressure to reduce the synthetic carbon black, petroleum-based carbon black, and also synthetic polymer as much as possible. Then we are trying to make nanocellulose to combine with natural fiber, natural rubber, with some additive. These are also bio-based, and the mechanical properties improved. And see, this is 60 parts carbon black and 12 parts CNF, almost comparable storage modulus and tensile strength also, even though the strain a little bit decrease. This is because the addition of CNF, additives improves more homogeneous distribution of the nanocellulose in the composite. Another subject is that the semiconducting liquefaction behavior of mechanically fibrillated cells. We have thought that the cellulose are not thermal conductivity, but under particular condition, they show such semiconducting properties and also liquefaction behavior. It means a plus minus, then electricity goes through, and the opposite not goes. So one way direction. These are another subject of we are focusing on the much more fundamentals. Okay, Kiitos very much.
Thank you very much, Professor Isogai. I'll take my questions here if there are questions from the audience. Really exciting to hear how many
Am I
fascinating... Sorry?
Am I a punctual presentation?
Yes.
Good.
Very punctual and very exciting.
Thank you.
Very interesting to hear what is happening in Japan, and so optimistic for nanocellulose, seeing all those applications. So thank you very much for that.
My pleasure.
Do you know how much nanocellulose is produced on a commercial scale in Japan?
Oh, it's a kind of confidential matter.
Okay.
But at least I think 100 ton per year.
Okay.
Or something. So Nippon Paper already installed the 500 ton per year system, but not 100% working.
Okay.
Yeah.
Then another question. So who would you say, if we think about these bio-based innovations, who would you say is driving the development in Japan? The government or the industry, or how would you see this?
Honestly speaking, it's both. Government are trying to, Japan has 66% land covered with forestry, but similar to Finland, but not so usefully used. Yeah, just leave as it is, and we are importing pulp from Finland, Brazil, or like this. So it's not optimistic. Many craft pulping mills are shut down, and still, 40, 50 years old craft, Kamiya craft pulping system maintained is used. So my personal opinion, it's a very pessimistic about the cellulose resources are produced from our own forestry.
Okay.
Yeah. So again, the government are trying to improve the cellulose utilization.
Yeah.
And the companies also, pulp and paper especially shrinking, so they are trying to change their enterprise to use cellulose or lignin and for the sustainable society. That's a driving force.
Yeah.
But I think slightly, going the death values. So government trying to, push up. Yes.
Well, that's great.
Yes.
Yeah. Do we have questions in the audience? Yes, there we go.
Professor Isogai, thank you.
Thank you.
Thank you for your presentation and the insight of the research that you do. And I noticed that a lot of a lot of topics were directly linked to industrial applications. So how much the research in universities in Japan are driven by the industry?
Okay, for example, in the case of nanocellulose, especially Tempo CNF developed our laboratory, already out of my hands, you know. So companies don't believe 100% in the laboratory activities. Okay, go ahead as a fundamental researcher like this, and the application we can do by ourselves. The company doing so, not so many open technologies, just focusing on the patent or like this, and suddenly we succeeded to make such products like this. So without my permission, no. Please go ahead by yourself. Something like such situation. Separated the role, fundamental for academic laboratories and applications companies.